All right, this is section 13.2 on balancing chemical equations. Here's the objectives. Be able to explain the roles of subscripts and coefficients and better know the difference between those. Be able to write balanced chemical equations for unbalanced ones and explain the role of the law of conservation of mass. All right, first of all, a couple things to keep in mind. In chemical reactions, atoms are never created or destroyed. That's basically the law of conservation of mass. You can't create matter, you can't destroy matter. You know, whatever you start with, you got to have at the end. So any atoms that you had in the reactants, they have to be there in the products when you're done. Okay, a balanced chemical equation, therefore, has to have the same number of each atom present. So if you have 5 atoms of oxygen, let's say, in the reactants, you better have 5 atoms of oxygen on the products. Whatever you have at the beginning, you got to have at the end. You know, the atoms that exist now are the same ones that have been on this planet forever. They don't get created or destroyed. They're the same things, still there. All right, so let's talk about the steps that you go through when you balance equations. First of all, step 1 is you need to know what the reactants and products are, and it says write a word equation for those. So kind of give just a very simple word equation about what you're looking for, what you. Second step is to then turn those words into formulas for the products and the reactants. Okay, and the third step is to change the coefficients. Now, don't change the subscripts on the reactants or the products. Once you have created those, that's how they are. They don't change. You can't change those just to fit this. You can only change coefficients. Keep this in mind. Only change coefficients when you're balancing an equation. This would be one of the most common mistakes people try to make, is they'll change the subscripts on reactants and products to make it work. Couple things to keep in mind. First of all, remember we have our diatomics. Here's our 7. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Make sure you remember those, because whenever it talks about those particular elements, they have to exist as diatomic molecules. Every other element would be a single element. So like copper, it'd be all by itself. But if we're talking about hydrogen, it has to be H2. If we're talking about hydrogen gas, it's H2, or oxygen gas. All right, so subscripts. Subscripts are part of the chemical formula. They are the thing. You know, so for instance, if we're talking about H2O, the 2 is a subscript. That is how that molecule exists, H2O. You can't take and say, oh, well, I need to get rid of one of those to balance my equation, and suddenly think that HO is water and not H2O. Don't do that. That is such a common mistake, and it shouldn't ever be done. Don't change subscripts. Write that down. Don't change subscripts. When you're balancing equations, subscripts. When you're balancing equation, don't do it. The only thing you're allowed to do is change coefficients. You may change these. Those are the numbers out front. Somehow, you have to adjust those numbers, whether there's 4 different compounds, reactants, and products here, or whatever they've got. Okay? Those are the only things that you can change when you are balancing an equation. I can change the numbers out front. I can change that. I can change those. I can't change anything else. So coefficients are the numbers out front. Coefficients are multiplied by everything in, there. So like, in other words, if I say 2AgNO3, it means I have 2 silvers, it means I have 2 nitrogens, it means I have 6 oxygens. Coefficients, it's like algebra where you had parentheses and you multiply. Okay? Subscripts, they only apply to the thing right in front of them, unless there's parentheses like there is over there. All right, let's do some examples. Balancing equations. It says write a balanced equation for the reaction that occurs between chlorine gas and aqueous sodium bromide to produce liquid bromine and aqueous sodium chloride. So, first of all, take the words, remember, and bromine, sodium chloride. So we should, step 1, is kind of write out what we've got. We've got some chlorine gas. We've got sodium bromide. it yields bromine, liquid bromine, and sodium chloride. So that's step 1. Okay. Step 2 is turn this into an equation. Turn it into symbols. So chlorine exists as Cl2. Sodium bromide would be NaBr. Remember, sodium's +1, Br is -1. Okay. Bromine says is a liquid. Bromine is diatomic 2. Okay. And we should put in, I haven't put in my state symbols, so let's put those in. AQ, liquid, and then sodium chloride, NaCl, aqueous. Okay, so here's my compound, or my formula, my equation. Now, I've gotten in my subscripts, I've got all those. I cannot change those. All I can do now is change the coefficients out front. I've got that set. And so I want to look. All right, so I've got 2 chlorines here, 2 chlorines on the left-hand side, and I've only got 1 here. So what I want to do is I want to put a coefficient in front of one of these that will make sure that they're even. Well, if I put a 2 in front here, remember the 2 is multiplied by everything, so it makes this 2 sodiums and 2 chlorines. So now I've got 2 chlorines on the left, I've got 2 chlorines on the right. Okay, so that's good. So now let's go on. Let's go to sodiums. Here in this sodium, I have 1 sodium, but over here now I put this 2, and so it says there's 2 of these, so now I've got to put something here to make it equal. So I'm going to write a 2 here. So I've checked chlorines and sodiums. Now let's check my my last thing is the bromines. And I've got a 2 here, so 2 times that, 2 times 1 is 2 of those, and there's a 2 over here. So there's my balanced equation. 1, 2, 1, 2. All right, let's do another example. Balanced equation for the reaction between aluminum sulfate. So, all right, we got to think of what aluminum sulfate. Aluminum's 3 plus, sulfate is 2 minus. Okay, aluminum sulfate. So here's, we'll just grab the words out here. Aluminum sulfate, calcium bromide yields, produces aluminum bromide, calcium sulfate. All right, so aluminum sulfate, if I look at this, it's going to be Al2SO4 in parentheses 3 plus calcium bromide. Calcium 2 plus, bromine 1 minus. So it's going to be CaBr2. And it's going to produce aluminum bromide. So aluminum 3 plus, bromide 1 minus. So Al3, AlBr3, try that. AlBr3 plus calcium sulfate. You can see those are even, so it's just going to be CaSO4. All right, now one of the things to keep in mind is that polyatomic ions like SO4 tend to stay the same on the other side. So notice there's an SO4 here, there's SO4s there. So when I balance these, I kind of think of the polyatomic ion, that SO4, as one thing. It's just easier than trying to think of it as a sulfur and 4 oxygens. It's just easier to think of it as SO4s. So we're going to balance, what we're going to try to do is we're going to balance aluminums, sulfates, calciums, and bromine. So that's how we're going to look at that. So let's start with aluminum. So we've got 2 over here, we've got 1 over here. I need to put a number in front over here so to give me 2. So I'm going to put a 2 there. Okay? So now aluminums are good, 2 on both sides. Let's take a look at sulfates. Okay, here I've got SO4s, I've got 3 of them. And I have over here, I have 1. So I've got to put a coefficient out front that's going to give me 3. So I put the 3 there. All right, now let's look at calciums. I've got the 3 now because I put this 3 here. By the way, you can never put coefficients in the middle. That is a no-no. That would be like cutting yourself in half and saying we're going to double the amount of legs by, putting a 2 in the middle of you. You can't do it, okay? Can't put them in the middle. So we can put that out front. 3, 3. So now we're good. And let's check out our bromines. Here I've got a 2 times, or a 3 times 2. Here I've got a 2 times 3, so there's 6. Now when you're all done, you can always just go back and double check, because sometimes you change things. So I've got 2 aluminums over here. Okay, I've got, if I want to be specific, I say I got 3 sulfurs, I got 3 sulfurs, I got 12 oxygens, I got 12 oxygens, or I could have just said, hey, I got 3 sulfates and 3 sulfates. I got 3 calciums, 6 bromine, 6 bromine. Okay. Sometimes they just give you skeleton equations, which is a little easier. They've already created the information for you, the compounds. Now, if they've given it to you, don't change them. They're telling you this is what it is. So this is going to be a 3, and that's a 3. Don't change anything on it. So, as we look at this, let's kind of look at how we would balance this. So right now it looks like ions are balanced, so we don't have to do anything there. But if we look at nitrates, we've got 3 nitrates here and only 1 nitrate, NO3s. Okay, only 1 over here. So I'm going to put a 3 over here to balance that out. Okay, now let's take a look at sodium. So I put this 3 here. That means I got 3 of them. I better put a 3 there. Now I've got 3 hydroxides. O3, OH3. I got 3 hydroxide. So here we are. That's our balanced equation. So my coefficients are 1, 3, 1, 3. And we don't write 1s, so we just leave those blank. All right, this is your turn. I want you to stop the video, and I want you to balance those 4 equations. Come back when you are done, when you have them all balanced, and we'll go over them and see if you did them right. All right, let's take a look at this one. If we're balancing calciums, 1 calcium, 1 calcium, carbon, 1 carbon, 1 carbon, oxygens, O3. There's 1 there, and there's 2 there, which is 3. So this equation is already balanced. And this is one of those, this is a polyatomic ion, but notice it didn't stay the same. Most of the time they do, but not always. This one kind of broke up into some different things. But this one is already balanced, so all 1s. All right, on the second one, I don't like usually starting with hydrogens when they're in a couple of different things. I don't like starting with compound or elements that are in, more than 2 different things. So let's start with sulfates instead. Let's go with SO4s. So notice over here I've got 3 of those, so I'm going to need 3 of these here. Okay, 3 sulfates. All right, so that took care of that. Let's look at aluminums. Aluminums, there's 1 there. There's 2 over here. So we better put a 2 in front. Okay, and if I look at... Now, this is kind of a little bit weird here, but if I want to think of this, this is, hydroxides, I could say, hey, I've got 6 hydroxides, and then here I've got 6 hydrogens. And a lot of times, if you want to think about this as polyatomic ions, you could think of water as a hydrogen and then a hydroxide, because that's how it acts. It reacts like that. And so, if we think, okay, I've got a hydrogen and hydroxide, I've got 6, so I need to put 6 there. If you don't like doing it that way, you can think, well, I've got 6 oxygens. I need to balance my oxygen, so there's 6. I've got 6 plus 6 hydrogens, or 12. 6 times 2 gives me 12. But either way, it works. And so what I get when I'm done is I get a 3, 2, 1, 6, if you did it right. Okay, let's take a look at this one. If we start off bariums, they're already balanced. So let's go to nitrates. Nitrates, there's 2 here. So let's put a 2 over here. Let's go to sodiums. Well, that we just took care of by putting that 2 there. Let's look at carbonates, CO3, CO3. Okay, so we're good. All it took was 1 number 2 right there. This one is kind of fun. All right, so let's take a look. All right, so we've got 2 carbons, so let's put a 2 here. Get that balanced. We've got 6 hydrogens, and we've got 2 here. So what number times 2 will give me 6? Well, 3 would. Okay, so 3 there. Now let's check out oxygen. So 2 times 2 is 4. 3 times 1 makes 7. There's a problem here. Okay? It's hard to get 7 when you have to have multiples of 2. There's no, the only thing that would work would be 3.5, right? Kind of hard to do fractions when we're doing this. So when you get in this case where that's what happens, you're trying to get to an odd number and you've got to get multiples of 2, what you have to do is you have to double everything else. Sometimes it is easier to think of this as, okay, yeah, it would take me 7 halves to do that. And now let's take everything on the equation, let's take the whole equation times 2. Well, so what would that do? That would give me a 2 there. That would cancel this out, so I'd have a 7 here. I'd have a 4 here. And I'd have a 6 here. And that's the final answer. 2, 7, 4, 6. Reactions like this, these are known as combustion reactions. You're burning something. About half the time you'll have to do this. Half time they work out where this is even and then you don't have to. Half time it works out where those are odd and you have to double everything. So, all right, there you go. That's the end of that section.